Hello all and welcome to the Algebra 1 video for multi-step equations. Okay, so in previous videos or previous lectures we've talked about how to solve 1 and 2-step equations. Well, now we're stepping into the realm of what we call multi-step equations. Okay, and multi-step equations are going to involve a few different things here. So first off, we're going to talk about the steps to solve a multi-step equation, and then we're going to look at a variety of examples. Okay, so first thing is, let's go over the steps. And the steps to solve a multi-step equation are, okay, first step is to distribute. Okay, and then notice here in parentheses, if necessary, not every single multi-step equation will require you to distribute anything. The key to know when to distribute something is, informally, we would say, is to look for parentheses. So if you see parentheses, generally that means there's some distributing that needs to go on. Okay, but once again, if not, as you'll see in example 1, there is no distributing that needs to be done. So in this case, you actually don't do step 1 because there's no distributing to occur. Now, once again, I keep saying distribute. Well, what does that mean? Well, that means we need to use the distributive property to simplify something. Okay, so distributive property to simplify something if necessary. Now, after we use the distributive property, we then go down to combine like terms. Okay, and then once again, if necessary. As you'll see in example 2 that I do, there's actually no combining of like terms that you have to do. Okay, so you only distribute, and then you go down to actually the third step, which is solve the equation. Okay, now once you distribute and once you combine like terms, what you should end up with is a 2-step equation, which at this point, hopefully everybody is comfortable in solving. Okay, so really this section is just really testing you and seeing if you understand, first off, how to use the distributive property, and then also how to combine like terms. Because if you do those two things, this bottom one's actually super easy. Just solve the equation, and it's going to be a 2-step equation, and you use the same steps that you've solved every single 2-step equation that you've solved up to this point. It's the same thing. Okay, so other than that, that's really all the notes that are really necessary here. So let's go ahead and jump into examples. Okay, so when we look at number 1 here, we've got 9x plus 1 minus 7x minus 5 is equal to negative 20. Now, once again, the whole point in this is we got something that looks really complex here. Now, if you wanted to, you could take this step by step and maybe like add 5 to each side, then subtract 1. But the problem here is we would have to do something with the variable terms, okay? So this is something hopefully you've at least talked about before in a class. If not, really pay attention to what I do here. But this example, we do not have to do step 1, okay? Because we do not have any parentheses here. So that's a clear indication that we do not have distributive property to do, okay? So all we have to worry about here is to combine like terms and then solve the resulting equation. So combining like terms, well, this is where a lot of people do get a little mixed up, especially when it comes to negatives and minus signs and things like that. So my suggestion is, and you'll see me do this in every example that I do here, okay? The first step that I always like to do before I combine the like terms is I like to rewrite my expressions with only addition. So I like to write my expressions as a sum. Okay, so what I mean by that is every single place. So here's subtraction. So instead of 9x plus 1 minus 7x, I've got 9x plus 1 plus negative 7x. So I took this subtraction and I wrote it as addition. But if I do that, the negative sign has to go with the negative 7. Okay, same thing over here with the minus 5. Instead of minus 5, I write it as plus negative 5. Okay. Now, the whole reason that I want to do this is this allows me to clearly see, well, if everything's addition, then all I'm going to do is add numbers. Okay, so that's one thing. It lets me just add numbers. That's all I've got to do. And then 2, it makes me makes it very clear as far as negatives or subtraction, what's really going on there, what I need to do with each of these numbers. So once again, if everything's addition, we're just going to add everything. So let's add like terms, okay? So the like terms here are going to be 9x and negative 7x. So what we would do is we would take 9 and add negative 7. And if we do 9x plus negative 7x, that will give us 2x. Okay, once again, that comes from the 9x and the negative 7x. Okay, then we're going to add to it. And this is where another nice thing about writing it as a sum is if you write it as a sum, then you know the next thing here has to be addition. Okay, so what we're going to do is we're going to add 1 and negative 5. Well, 1 plus negative 5 gives us negative 4. Okay, and then we still have the equals negative 20. We haven't done anything to the right side of the equation yet because our whole point here is we're writing and combining our common terms or our like terms so that way we can make it into something simple that we know how to solve. And from here, we actually would know how to solve this, except for I'm going to take it one step further. And instead of 2x plus negative 4 is equal to negative 20, I'm going to rewrite it one more time as 2x plus a negative is the same thing as minusing the positive. And now we've just got a generic two-step equation that we've solved a million times before now, okay? Where, of course, we would add, which I need to get rid of these equal signs over here. Whereas what we would do is we would just add 4. So the negative 4 or minus 4 and the plus 4 go away, give us the 2x is equal to negative 20 plus 4, negative 16, divide by 2, divide by 2. So we get x is equal to negative over a positive is a negative, 16 over 2 is 8. And that's actually all there is to it. Okay, the hardest part is simplifying to a point where we get a two-step equation. And once again, I'm hoping at this point everybody's okay with what I just did right here in terms of the the steps for doing the two-step equation. Okay, so once again, it's just a two-step equation. Solve it like we've done before. Okay, number 2, in this case, as I said in the introduction, there is we have to distribute here because we see parentheses, and what's going on with the parentheses? Well, we've got negative 7 times 3a minus 1. So we got negative 7 times some stuff in the parentheses here. So that indicates to us distributive property. But as you'll see, this example doesn't use any, we don't have to do any combining of like terms, okay? So what we do, well, first step is I see that the variable that I have is over on the right-hand side. So once again, you can definitely solve it from over there, but I like to rewrite my equation with my variable on the left-hand side. Okay, so all I've done here is I've rewritten my expression, just flipping the sides over. Symmetric property, if you remember that, allows us to do this. Okay, and now we just have to distribute. Well, what are we distributing? Well, we're distributing this negative 7 to the 3a and to the technically negative 1, but you'll see why I say that here in just a second, because once again, I'm going to rewrite this as a sum. So even if the subtraction's inside the parentheses there, I write it as a sum. So now when I distribute, what am I distributing to? 3a and negative 1. So negative 7 times 3a, negative times a positive is a negative. 7 times 3 is 21. We can't forget the a. Plus negative 7 times negative 1, well, that is a positive 7. Okay, and then once again, the right side of the equation now, we're not doing anything to that 91 yet. But now we've got a two-step equation where we will subtract 7. Once again, those go away. Looks like the 4 is over there. Negative 21a is equal to 91 minus 7 is 84. and then we divide both sides by negative 21. So once again, those go give us 1. So negative over negative, positive. 21 over 21 is 1a, which is what we want. And then we have a net positive over a negative, which gives us a negative. 84 over 21. Bigger numbers here, but if you're clever enough, you could probably do this without a calculator. 84 divided by 21 is 4. Now, I do have to say, I don't want anybody relying on the calculator by any means, okay? But I would definitely prefer you double check yourself if you're unsure on a calculation. Double check yourself on a calculator than just try to guess and give the wrong answer, okay? So try your best, and this is my thing, is try your best to maybe guess what it is, and then just check yourself on the calculator and see if it's right. And then if it's not, then you can change it, okay? But like I said, basic arithmetic here, basic solving of two-step equations, it's just we had to distribute first. Now notice we didn't have to combine any like terms here. We had a variable term with a and then a constant term of 7. We can't add those together, okay? So that tells us that's the steps that we need to do to solve the equation. Now going on to number 3, now we get our first taste of a combination, okay? Now, once again, we got to be very careful here, because if you just look at this, you see the parentheses, you say, I need to distribute. Well, if you actually look at it and you say, well, I'm going to distribute a 5, let's say. All right, that's obvious. It's a 5 right here, so I'm going to take 5 and multiply it over. That if you think that way, that's actually incorrect, because you got to pay attention to what's in front of the 5 here. So you've got 4m minus 5 times 3m plus 10, and then all that's equal to 126. So once again, if you see it right now, that's very good, but let me show you. Because if we write it as a sum, then it's clear what we have to distribute by, okay, or distribute. So in this case, 3m plus 10, that's all a sum anyway. So the only thing we had to change there was the 5 to a negative 5, okay? So what we've got here is 4m plus, well, we're going to actually distribute the whole thing negative 5 to each one of these terms, okay? Once again, I wrote this as a sum, and when I did that, it kind of opened it up to show me that, hey, what I'm actually distributing is a negative 5. So I write everything that I'm not distributing again, so 4m plus negative 5 times positive 3 is a negative 15, and then we can't forget the m because that's a variable term, plus negative 5 times 10 gives us negative 50. And now we've got to do step 2. So now we got to combine like terms. Well, we have only one constant term, but we have 2 variable terms with m. So we need to add 4 and negative 15. So 4m plus negative 15m, that gives us negative 11m. And then everything else stays the same. And then once again, from here we could probably solve it like this, but I'm going to take it one more step. So I don't have to deal with this negative number plus a negative is the same thing as subtracting the positive. So now we have simply the equation negative 11m minus 50 is equal to 126. So we add 50. At this point, I'm kind of going to gloss over this because everybody at this point should be able to solve a two-step equation, especially if it's in this form, because it's exactly the same steps we've done every single other time. So negative 11m is equal to 176, so divide by negative 11, divide by negative 11. M is equal to positive over negative, negative. Once again, this is another one. I don't really expect many people to do this one in your head, but if you can think of it, the answer here is actually, once again, positive over negative, negative. 176 over 11 is 16. So the answer is negative 16. Okay. But notice here we had to combine the two. We actually had to distribute first. So once we distributed, then we could combine our like terms. Okay. And once again, after we do those two things, we just have a two-step equation that we use the same steps we solved every two-step equation with to solve. Okay. Number 4, going a little bit more difficult here because once again we see two sets of parentheses. So that actually indicates to us that we're going to have to distribute 2 times. Okay. But once again, I see this. Very first thing I'm going to do is I'm going to write it as a sum. Okay. So let me fix that right there. So that way not as much space so I can write the rest of it. But here's where we run into a little problem. Plus what? Well, what's the number that's in front of this parentheses here? Well, just like a variable, if we just have a k here, that's technically a 1k. Well, that's technically a 1 in front of our, or behind our negative sign in front of our parentheses, okay? So what we've really got here is we're going to be adding -1 times k plus 5. And then once again, all that equals to 23. So now we see, well, what are we distributing? Well, we're distributing -3 to k and -8. And over here, we're going to distribute -1 to k and 5. So doing all this together here, -3 times k, well, that's just -3k, plus -3 times -8 is a positive 24. Once again, negative times a negative is a positive, okay, and plus positive 24. Then we're going to add to it -1 times k. Well, that's going to be -1k. Plus -1 times 5, that's going to be a -5. Once again, all that equal to 23. So now that's all the distributing we need to do. Let's combine all the like terms. So we've got -3k, -1k, so -3 plus -1 is -4, and then we still have the k. Plus, we know it's going to be a plus because everything up here is plus. That's part of the advantage of writing everything as a sum. Now we've got 24 plus -5, which is a 19. And now you can see why, since we've written it this way, it makes it super easy. Now we've just got a two-step equation, which everybody at this point should be able to solve. So we are going to subtract 19. Subtract 19. -4k is equal to 23 minus 19 is 4. Divide by -4. Divide by -4. Those go away, giving us 1k. 4 over -4. Positive over negative is a negative. 4 over 4 is 1. So our answer is actually just -1. Okay. So once again, the steps here were, we saw we had to distribute first, then combine the like terms. And once we combine the like terms, we should have a equation in normal form, or in the form that we're used to solve as a two-step equation. Okay. So let's go on to number 5. Same kind of thing here. Okay. Once you've seen one, you've like that last one. Once you've seen how to do that one, every single one of them works almost exactly the same way. Except in this case, we got the number on the left-hand side. Our variable stuff is on the right. So first thing I want to do here is I'm going to rewrite it, flipping it around. And then once again, I see I've got subtraction here. So a lot of people want to just jump in and try to distribute a 6 because it's 6 times 2x plus 5. But this is where, once again, you see me do this every time. If I have subtraction, I write it as a sum. Because once again, if I write it as a sum, now it's clear to see, well, what should I actually distribute? -6. And eventually, if you do these enough, you might be able to see, okay, well, I've got -6. You can see that I need to distribute a -6. But like I said, if you're having trouble with this or you're just starting this out, definitely write it as a sum so you can see exactly what I'm going to distribute. Because I'm going to distribute this to both the 2x and the 5, okay? So once again, the 10x has nothing to do with the distributing, so it comes back down. Everything stays the same. But negative 6 times 2x would be negative 12x, plus negative 6 times 5, which is negative 30, still equal to 20. We didn't do anything to the right-hand side. And now we do the same steps we've done before. We just distributed. Now we combine like terms. So the terms we can combine here are 10x and negative 12x. So 10 plus negative 12 gives us negative 2, once again, x plus the negative 30, since that's the only constant term on the right-hand or left-hand side. And then, like I said, from here you can actually do it. You could subtract negative 30 from both sides and solve it like that. But like I said, subtracting and dealing with negatives is a little tough, so I'm going to take plus negative 30 and rewrite that as minus 30. And then, once again, 2 steps. Add 30. And divide by negative 2. So we get x is equal to positive over negative, negative, 50 over 2, negative 25. Once again, you see that I take up a lot of space, okay? So that is the thing. You do have to show all your steps and show all your work, but if you do take it step by step, yes, there's, technically, if you include the first line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines here to solve one equation. But, once again, same exact steps every single time. So no matter what type of equation you have like this, if you follow the same steps, you could have a 100-step equation, okay? Now, am I going to give you a 100-step equation? Are you ever going to have to really do a 100-step equation? Probably not, no. But if you follow the same steps, you could actually solve a 100-step equation by doing this, okay? Once again, it's just the same kind of thing. Here we see we're going to distribute the 8, but you see some subtraction here. So once again, if you can get to the point where you can do this without writing it as a sum, that's perfectly fine. But like I said, especially if you're struggling or you are just starting this out, don't hesitate to write everything as a sum. Because now we see I'm distributing the 8 to a 2w and a negative 1. And then over here, I'm going to be adding a negative 4w. So once again, everything's addition. So now when I distribute, it's clear what I need to multiply. 8 times 2, that's 16. Well, there's a w with it. Plus 8 times negative 1 is negative 8. Then we still have plus the negative 4w is equal to negative 116. So same kind of thing here. We got 16w, negative 4w. 16 plus negative 4 is 12w plus negative 8 is equal to negative 116. And then lastly, like I said, you could probably solve it from here just like we did right here, like you saw that you could do right here. But I am going to go the extra step, and I'm going to rewrite this as 12w minus 8 is equal to negative 116. And then once again, even though the numbers are a little bigger here, negative 116, we can actually still just solve it like normal. Add 8, those go away, so we get 12w is equal to negative 108. Okay, and then from there we divide by 12. W is going to be equal to negative over positive negative. 108 divided by 12. Once again, might be harder to think about here, but that is going to be 9. Okay, once again, if you need to double check yourself on a calculator, I have no problem with that. Okay, especially with these bigger numbers. This might be something you kind of maybe should remember from your times tables, if you remember those back in 3rd or 4th grade. Okay, but like I said, it's not the end of the world if you don't know how to do 108 divided by 12. I do not mind if you use a calculator to check yourself with that, okay? But the answer there is negative 9. Once again, I wrote it as a sum, okay, distributed, combine my like terms, and then solve the two-step equation, resulting two-step equation. Okay. All right, number 7, same kind of thing here. We see we have subtraction, so I'm going to write it as a sum. But before I do want to point out this is minus, and then you just see the parentheses, 2h minus 1. Well, once again, if there's no number in front of the parentheses, you can automatically put a 1 in there, okay? The same with a variable. If you just have an h or just have an x, you can put a 1 in front of it and it doesn't change anything. And it actually helps us here because now when we write it as a sum, we can see, well, what are we going to have to distribute? Well, we're going to have to distribute a -1. That's what we're distributing. Okay, so we have 11h plus -1 times 2h is -2h plus -1 times -1 is a +1 is equal to 118. 11h plus -2h, so 11 plus -2 is 9h, and we still have the +1 is equal to 118. And then two-step equation time. That's all we got to do. -1 minus 1, 9h is equal to 117. Divide by 9, divide by 9. H is equal to, and once again, this is another one where I don't expect you to do this. This is one that you probably didn't have in your times tables because you normally only went up to 12, because 117 divided by 9 is 13. So H is equal to 13. But once again, see the same steps. The only thing we had to remember this time was put a 1 in front of the parentheses if there's no number, okay? So since there's no number there, I can put a 1. That means I'm distributing a -1, and then that tells me all my terms, which I just combine into a two-step equation. Number 8, see a fraction. Okay, but actually this is actually super easy because the fraction is a half and we have two even numbers in here, but that's where the distributive property is going to come in. But before that, I am going to rewrite this because I don't like my variables on the right-hand side. Once again, it's perfectly fine if it is on the right-hand side, but just for the sake of ease and sake of consistency, if you write it the same way over and over and over again, once again, they work exactly the same every time. Okay, except for in this case, we're going to be distributing a 1/2. But before I do that, once again, I'm going to see I've got some subtraction here. I'm going to rewrite this as a sum. So now, when I see that I'm distributing the 1/2, I'm distributing it to a 10x, and I'm distributing it to a -2. So 1/2 of 10x. So technically, this one you probably don't need a calculator on, because if you think what's 1/2 of 10, or 1/2 of 10 is 5x. Okay. Plus, what's 1/2 of -2? Well, 1/2 of 2 is 1. Positive times a negative, so this is going to be a -1. But I do know in that case, negatives do tend to throw people off, and fractions tend to throw people off on top of that as well. So like I said, if you need to double check yourself, I have no problem with you double checking yourself on a calculator, but I would hope with the fraction of 1/2 and even numbers, that should be a little, more doable than normal. But then we look and say, well, we have 5x and we have 3x, so 5x plus 3x, that's 8x plus the -1. And now I'm going to rewrite it one more time as 8x minus 1. So now, once again, I don't have to deal with any negative numbers on this side, so all I got to do is add 1. Those go away, so we have 8x is equal to -24. Divide by 8, divide by 8, boom. X is equal to positive over a negative, or negative over a positive is a negative. 24 over 8 is 3. X is equal to -3. Okay. So we introduced a fraction here. This is a pretty easy fraction example, okay? But I do have to say, we go to the next one. It gets a little bit more complicated, a little more tricky, okay? Because we end up with the fraction 5/2. we can see we're subtracting it. So if you've been following along with me and understand, that means we're going to be distributing a negative 5 halves. Okay. So once again, we're getting a little bit more, complicated here. But once again, first thing I'm going to do is I see all this subtraction. I'm going to write it as a sum, just to get rid of all that subtraction. So that way all I have to deal with is addition. Okay, so once again, we see what's the number in front of this set of parentheses? Well, it's the negative 5 halves. And that's what we're distributing. Okay, so the 7's still going to be there. The negative 5 halves times 8 and the negative 5 halves times negative 6. Once again, those are a little trickier to do in your head. Okay, still not impossible. This denominator of 2 down here makes it a little bit easier because if you think, well, 8 divided by 2 is 4. Negative 5 times 4, well, that's going to give me negative 20r. Plus, negative times a negative is a positive. Well, 6 divided by 2 is 3. 3 times 5, that should be 15. Now, once again, I don't expect everybody to be able to do that in your head. So, once again, and I don't know how many times I can say this. I'll probably say it 100 more times. But double check yourself on a calculator if you need to, especially when it comes to fractions and negative numbers. Okay, I'd much rather you double check yourself and make sure negative 5 halves times 8r is negative 20r than just guessing and saying, oh, it's, 16r or something. I don't know. But then at the same time, we still have this 2r over here, and all that's still equal to 32. And now we're at a point that we have been in every single one of these other questions. We have negative 20r, we have 2r, so negative 20 plus 2 is negative 18. And then we got to include the r. 7 plus 15, well, that's 22. And now a normal old two-step equation. Or is it? Well, let's actually do the steps here. Those go away. Negative 18r is equal to 10, positive 10. Divide by negative 18, divide by negative 18. Those go away. So r is equal to negative, so positive over negative is a negative. 10 over 18, well, that's actually just a fraction. But, so that's a possible answer. You can get fractional answers when you solve equations. But we got to remember is that's not actually the final answer because we have an even number on top, even number on bottom. We can actually take a 2 out of top and bottom. So we can simplify this fraction. So what that means is this is going to become negative. If we divide 10 by 2, we get 5. If we divide 18 by 2, we get 9. So the answer is actually negative 5/9. If you give the answer as negative 10/18, technically that's correct in a sense that if you do that fraction, if you do 10 divided by 18, it'll give you the same decimal as you get when you do 5 divided by 9. But technically in math, to have the most correct answer, it needs to be the simplest, meaning if you have a fraction that can be simplified, you need to simplify it, okay? So in this case, if you have a fractional answer, make sure your fraction is simplified, okay? But once again, notice the steps. Every single step's the same. The only thing we had to worry about down here was we had a fractional answer, so we needed to know how to simplify it. Now, if you have trouble simplifying fractions or you get fraction anxiety, please let me know so that way we can help with that because I'm just going to be honest with you. From here on out, you're going to be seeing more and more and more fractions as we go along, okay? So just be aware of that. But like I said, every single step's the same. It's just that we got fractions here, and a fraction is an answer, okay? But the answer is actually negative 5/9. And the last question, if you look at the paper, it says translate and solve, so challenge ahead. This is actually like a challenge type question in that if you look at the equation here, well, we have an equation. It's just written in terms of words. So what we have to do is we have to translate this first, then do everything we've been doing with all these other questions and actually solve it. So first off, let's translate 5 times. So we know we're going to do 5 times what? the difference of twice a number and 3. Well, since we're doing 5 times the difference, that indicates to us we need parentheses. If it was just 5 times twice a number and 3, well, that would just be 5 times twice a number. And then we would add 3, I guess. But in this case, 5 times the difference tells us we're going to take 5 times and we're going to multiply it times the difference. Well, here's where we got to think back to the very first stuff you probably ever talk about in algebra, which is expressions and verbal and algebraic expressions. The word difference means subtraction. So we know there's going to be subtraction here. So let's go ahead and write that down. Well, what are we subtracting? Well, we're subtracting twice a number, which means 2 times a number, and 3. Okay? So that's actually that first part. 5 times the difference, and once again, since we're multiplying it times the whole difference, we have to include parentheses here. If we wrote it without parentheses, so if we just wrote it like this, what's actually being multiplied times 5? Well, 5 is multiplying just the 2x. But if we put the parentheses, it tells us 5 is actually multiplying the whole difference or the whole subtraction here. Okay? So then we go on. So that decreased by, okay, so we're decreasing it by the sum of a number and 8, or sum of the number. So they say the number because we're using the same number here, okay? But once again, we're decreasing it by the whole thing, the sum. Well, once again, you see the word sum probably indicates you need to use parentheses. So sum of what? That same number that we have and 8. So sum meaning addition. We're going to add the number that we talked about before, which we called x. Okay, that's what we have there. And to wrap it all up, that's equal to 13. So if we rewrite it a little bit in the nicer terms, 5 times 2x minus 3 looks like this, minus x plus 8 is equal to 13. And now we have an equation that looks very similar to the ones we've been working out this whole time. But like I said, we write it like this. We see we have subtraction. I'm going to rewrite it one more time with addition. So I'm going to write it as a sum. Except for we do have to realize that there's no number in front of this. So technically we could put a 1. So that means we're going to be distributing a negative 1. So what are we distributing? Well, 5 to the 2x to the negative 3, negative 1 to the x and to the 8. So 5 times 2x gives us 10x, plus 5 times negative 3 is negative 15, plus negative 1 times x is negative 1x, plus negative 1 times 8 is negative 8. So then once again, we did the distributing there, so use the distributive property. Now we combine like terms. 10x plus negative 1x is 9x, plus negative 15 plus negative 8, it's going to be negative 23. Okay. And then once again, I'm going to rewrite it one more time as 9x minus 23, as I've done with all the examples that came before. And now just a two-step equation. So add 23, 9x is equal to 36, divide by 9, divide by 9. That means x is equal to 4. Okay. Now, I do have to say on the homework, there's not a question that's quite like this. Okay, this is kind of just a challenge question just to show you that, hey, you can have it written out in words. And if you can write it out in words, then you can convert it into an algebraic expression. Okay, so we went from a verbal expression to an algebraic expression, and now we can actually solve the algebraic expression like we've done. So the answer to this, so this number that we wanted to figure out, so this number is 4. And you can think about it. Twice a number is 8. So if we take 8 minus 3, that's 5. 5 times 5 is 25. Then we go over here, a number and 8. Okay, so subtract a number times, or number plus 8. So 4 plus 8 is 12. 25 minus 12 is 13. Okay. Now, like I said, there's not a question like this on the homework, but it is good practice. So in this case, doing it as an example of seeing how we can go from verbal expressions to algebraic expressions and actually solve the algebraic expression and solve the algebraic equation in this case. Okay. But with that being said, that's all the examples that I have here for you. The big thing in total, okay, if you don't take anything else away from this, do not be afraid to write your expressions as sums, okay? Notice every single example I've went through. I've written it as a sum. That way I can easily distribute and I can combine like terms. And then the last step, that should be the easiest at this point, which is just solve a two-step equation, okay? Like I said, I know some of these, a lot of people look at this and they see all these numbers and letters all over the place, fractions even, and they get overwhelmed. But once again, take it step by step. Like I said, I strongly suggest writing it as a sum so you can clearly see what you're multiplying together, what you're adding together. So that way, when you get to the end, you just have a simple two-step equation to solve. Okay. But with that being said, attempt the homework, see what you can do with that. If you run into any questions or issues, please let me know. But other than that, thank you for watching.